Hey everybody. Thanks for having me and thanks for sticking around. Can everybody hear me? Okay, great. See how the thing works here. And my name's Trent. I'm going to talk to you just kind of a high-level discussion of some corrosion-resistant reinforcing materials that we've been looking at Bridge Division and at TxDOT. So to begin, I just want to touch on what steel corrosion is, tell you about what TxDOT currently does, and then one by one, just take a quick look at what these new reinforcement materials are. Give you an idea of some basic information so we can make decisions about using them. So, steel corrosion. You know, in fresh concrete, steel, black steel, carbon steel, doesn't have any problems. Fresh concrete's a high alkaline material. pH's around 13, steel has no trouble. Steel's not gonna have trouble unless the pH drops around, probably below 10 or 11. What happens is that water, air, and especially chlorides can get through that concrete. They can lower that pH, and once it does, steel does corrode. Real problem here is when it corrodes, the corroded material begins to take up about 7 times more volume than it used to. So we're basically inflating a bunch of little tiny balloons inside the concrete. This causes tensile stresses, opens up cracks. More chlorides now get to the rebar, and now we're talking about section loss and real capacity issues. So that's what we're dealing with. So what does TxDOT do about it? Well, these are some bridge recommendations that we have. If you want to take a closer look at these, and I encourage everybody to do so, just Google TxDOT corrosion. It'll be the first thing that comes up. And these are district-wide recommendations in the shaded counties up here. You know, Texas is too big to have recommendations, many recommendations statewide. When it comes to corrosion, it's a different animal in Austin than it is in Amarillo. It really comes down to where it gets cold and where we use de-icing salts. So that's kind of what you're seeing with the shaded counties here. So what you'll see, TxDOT, we do a really good job with our concrete, and that's our first line of defense against corrosion. First thing we do is bump up the clear cover. Now, these recommendations were issued in 2013. Since that time, we've actually decided to go with 2.5-inch clear cover over the top mat of reinforcing in all of our bridge decks. But the substructure also needs attention a lot of the time, and in a highly corrosive environment, we say go ahead, case-by-case basis, if you need to, bump that clear cover up to 2.5 inches, maybe 3 or 3.5, but you know, too much more than that, we're talking about unreinforced concrete, and that's a whole other problem. Other thing we do, high-performance concrete. We produce a lot of Class S fly ash in this state, and this is a good place to put it. When I say high-performance concrete, that really just means low permeability concrete. And the idea is just like clear cover. We're slowing down the migration of these chlorides. Now, another thing we do is air entrainment. We all know about freeze and thaw cycles in the northern part of the state. Air entrainment helps us to avoid cracking from those stresses because cracking would allow the chlorides to come in faster. There's one thing I'll mention about this is that we do like our Class F fly ash. We like air entrainment. But Class F fly ash and air entrainment don't get along together. Class F is in the mix. It becomes kind of difficult to hit our target air content. So we don't specify air entrainment statewide. We limit that to the northern parts of the state where we really need it. Now, topic of the presentation, corrosion-resistant reinforcing steel. The way that started off for us and for everybody else really is epoxy coated reinforcement. We've all seen it. Blue counties here where we recommend it based on exposure to de-icing salts. So it's not the only one. And you know, we say that corrosion measure is to use epoxy coated reinforcing steel. The measure again was written in 2013, and at this point I can say if we say use epoxy coated reinforcement, use any of these materials. I'm going to talk about a few of them today. And I'm going to talk a little bit in terms of performance and cost. So carbon steel, or regular steel, it's the cheapest and it has the most trouble with corrosion. Epoxy coated, a little bit more expensive, performs a little bit better. Higher end of the scale, we got stainless steel. In between, we've got today's presentation. We've got galvanized rebar, glass fiber reinforced polymer, dual coated, and even low carbon chromium steel. I'm not going to get up here and tell you which one is the best, which one is the best performing or the least expensive. There's a research project listed up here, and I encourage everybody to follow that project if you're interested in those questions, because that's where they're going to be answered. But now let's just take a look at these one by one. Epoxy coated. Again, we all kind of know what this is. What I'll point out, the coating thickness is 7 to 12 mils, mils being millet inch. If you've seen it in the field, I've always seen it green. We have two different ASTMs we can specify it by. If you see green epoxy coated rebar, that means it was done by one process, a process that allows it to be fabricated after it's coated. If you see somebody bending a green bar, it's okay. Purple rebar, purple epoxy coated rebar that is a different kind of coating. And after it's coated, it can't be fabricated. So if somebody's bending a purple bar, or a gray one, same thing, that's a bad thing. The holidays with epoxy coated reinforcement, you've probably heard of that. Holidays are little holes that you can't see with your naked eye, but the chlorides, the water, they can find it. And if the holes are there, the rebar underneath them is not safe. Epoxy coating, all these that we're going to talk about today, they're in item 440. I'm not going to go through this line by line. I just want you to know that it's there. Now, hot dip galvanized reinforcement. Hot dip galvanizing is basically dipping metal into a bath of molten zinc, and the zinc helps the material to fight corrosion. There's two classes of hot dip galvanizing for reinforcement. Class 1 and Class 2 listed up here. The thicker one is Class 1, and you might think, well, the thicker coating is going to be the stronger coating. But if you fabricate the bar after you've hot dipped it, and you're using that thicker coating, it might look something like this picture here. And I don't know if y'all can see the detail from the back, but there's a lot of chipping in that galvanized coating, and that's kind of defeating the purpose here. So the takeaway here is that hot dip galvanized reinforcement is going to perform better if you fabricate it before you dip it. You can use Class 2 to get a more ductile coating, but I would still say let's fabricate this stuff before we use hot dip. It's in item 440 again. But there's another kind of hot dip galvanizing now, continuous. So instead of just immersing in a bath of molten zinc, now we're passing it through, and we're adding aluminum to that bath. What that means is that the zinc is going to be better adhering to the metal, to the rebar. We can get down to a 2 mil coating, very thin. And this shown here, this was continuously hot dipped as a straight bar and then fabricated into this tight spiral. And there's no flaking here. This has the potential to be a very good product. But it's new. We don't know that much about cost and performance yet, and it's not in item 440 yet. But keep an eye on the special provisions, because we've got our eyes on this, and I think it's coming. So we've talked about epoxy coated, galvanized. Dual coated is just both. So it's the one we just talked about, continuous hot dip galvanized bar that's then epoxy coated. And the epoxy for these guys is yellow. And now it's just like you'd expect. It's belt and suspenders. It's probably going to have a higher performance level. It's probably going to be a little bit more expensive. But this is one of the materials that's specified by an ASTM, yet is only produced by one manufacturer. And right now, it does not seem to be available from that manufacturer. So if you'd like to use this, just a word to the wise, check the availability first. And as shown down here, this is in item 440. Now let's kind of change gears a little bit. So everything up to now that I've talked about has been regular carbon steel with some kind of jacket around it, some kind of coating. Glass fiber reinforced polymer is not steel. There's no steel in it. It is just glass fibers surrounded by a resin or a polymer resin material. So the glass fibers are carrying tension. The polymer material is just protecting the glass fibers. The design, the material specifications for glass fiber reinforced polymer are all available in an AASHTO guideline specifically for GFRP. We're still on the first edition. It's about 8 years old now. Second edition is being worked on. I would imagine we'll see it in a year or two. Big thing about the second edition, TxDOT, we like empirical deck procedure for our rebar. Right now, that does not apply to GFRP. In the second edition, it will. So that's going to help us implement this material, I think. We already, though, have the standard out, IGFRP. So if you're interested in using this material, and we'd like you to be interested in using this material, take a look at this. This is for text skirted bridges, standard bridges. Give you a detail to throw some IGFRP in that slab. And I'll mention the Canadians, they use more de-icing salts than we do. And they have a lot more experience with this particular material. We've learned a lot from them. We've looked at a lot of their research. Only other thing I want to mention here, cannot fabricate this material. Bins have to be incorporated into the manufacturing process. And running low on time, so again, it's in item 440. I want to mention low carbium chromium steel. The deal here is that this is not a coating, this is a different kind of metal. Some of the carbon we've replaced with chromium. That's expensive, but the more chromium you have in your steel, the better it can fight corrosion. So this only comes in high strength, 100 or 120 KSI. We only allow 100 KSI. There's 3 alloys to know about. We only allow the highest chromium content alloy. However, the other 2 probably are okay, maybe okay. We just haven't tested them yet. No special handling requirements because there's no coating that can get messed up. So there's some nice things about this. It's another one that's only available from one manufacturer, even though we just specify it by the ASTM. It's in item 440. But you also need to look at the special provision to item 440. That's where some of the additional details come in. Which takes us to the Rolls-Royce of reinforcement, stainless steel. This is just an extension of low carbon chromium steel in a sense because we're just adding more chromium. Low carbon chromium steel, we were up to about 10%. Here we're talking about 15 to 25% chromium. There's 2 classes, austenitic, duplex. Big takeaway is austenitic is not magnetic. Duplex has a magnetic field associated with it. So if we're talking about somewhere near a toll road or somewhere with electronic scanning, probably want to stick with austenitic. This table here divides what we allow into austenitic and duplex classes, lists the chromium content. This will give you an idea of what to specify, and be sure to list exactly what you want to specify in your contract documents, because these things all have different price tags. And I'll just mention, stainless is available as a cladding for carbon steel. That's not what we do at TxDOT. If we're going to spend this kind of money on rebar, we want the real thing. So we're going to get solid bar. With that, thank you. Does anybody have any quick questions? Okay.